Here we have a straightforward setup to look at the electrical conductivity of some ionic compounds, both in solid form and in solution. First, let's just make sure, yep, there's our very simple circuit from the power pack through the lamp and back to the power pack. That part's nice and straightforward. That's just testing our circuit. We can see, yep, the lamp should glow. Now we're not going to go from the power pack straight to that lamp. We're going to be using these electrodes, these graphite electrodes. So let's just test again to show that, hey, with these graphite electrodes, doesn't matter, the lamp still glows if we touch these electrodes. And remember to turn the power pack on. Now if we touch those electrodes, sure enough, the lamp glows. Right, so there's a straightforward, simple circuit. Now we have sucrose, that's your basic table sugar. We have some hydrated copper 2 sulfate and some sodium chloride, that's just salt that you'd put on your fish and chips. So let's look at sodium chloride first. Let's look at some salt. Well, we'll put a bit on this watch glass here. Just tip out a bit of salt onto the watch glass. Now, an ionic compound is made from ions, which are charged species. Electrical current is a flow of charges. A lot of people think it's a flow of electrons. Well, it's really charges. The charges are often electrons because we're often talking about electrons moving through a wire. But it doesn't have to be electrons. We just need charges. Ionic compounds like the salt are made of ions which are charged chemical species, but they're fixed in the lattice. They can't move around, so we can't have a flow of charges. Even though we've got charges, they can't move. So when we touch these electrodes, remember, yep, lamp is glowing, complete the circuit. When we touch the electrodes to the salt, we find that the lamp doesn't glow, because whilst we have charges there in the ionic lattice, they can't flow. There is one easy way to dissociate that ionic lattice into the constituent ions, and that is to put it in water. So I have some deionized water here. There you go. I'll show the camera officially. Deionized water, not straight from the tap, but made in the science lab. Actually, let's just test another beaker. Let's just show that water is actually a very poor conductor of electricity. If the current is high enough, it can conduct a little bit because water self-ionizes, it self-dissociates, but only 1 in every 10 million water molecules, so it doesn't conduct very well. So one electrode in, other electrode in, and you'll note the lamp isn't glowing. So any glow that we see is not because the water conducted current. As I said, water is a very poor conductor of electricity. So back to our salty water now. I'll give it a bit of a stir. Some of the crystals will have dissolved already. You can see we've still got some on the bottom. They haven't all dissolved, but that's fine. If we stirred it for long enough, gave it a good enough mix up, they would. But this will do for now. Let's just drop one electrode in, and then we'll put the other electrode in. Remember, as a solid compound, this did not conduct current, but now it does. You'll note actually not as bright as if I touch the electrodes together, brighter, but the salty solution definitely does conduct current. That lamp really is glowing. Let's try one of the other compounds we have. Put that salty water aside. Now I will just dry off those electrodes. We don't want any results from the next part to be declared, no, that was from the first part. Nope. Okay. Dried off the electrodes. We'll get a fresh watch glass, and this time we will test our hydrated copper 2 sulfate. Copper 2 sulfate pentahydrate. Now this sometimes clumps, so I don't want too much to come out. Let's So I'll use a spatula. And now we'll test our copper 2 sulfate. Electrodes touching, lamp glowing. But electrodes pushed into this salt, this ionic compound. Remember, in chemistry, an ionic compound we refer to as a salt. One of them happens to have the common name salt. But we can see the lamp is not glowing. Electrodes touching, we can complete the circuit, but placed into the copper 2 sulfate, we don't have a flow of current. So let's take that copper 2 sulfate, put it into our water. Give it a bit of a stir up to help some of those ions dissolve, to be pulled out of the lattice. And now, because we've got ions removed from the lattice, they're free to move throughout the solution. That means they can flow, so we can have a flow of charges, which is electrical current. And sure enough, the lamp is glowing. You'll note not as bright as with the salt, with the sodium chloride. Certainly not as bright as if I just touch the electrodes, but it is glowing. Some ionic compounds completely dissociate very readily into their constituent ions. Some ionic compounds will dissolve, but not as easily, not as readily. What we have, the solution with the ions that are free to move, we call an electrolyte. But we can have strong electrolytes or weak electrolytes. So we can see the copper sulfate, whilst it did conduct current, it was a weaker electrolyte than the solution of sodium chloride. Now we have one more compound to test, and that is the sucrose. This is your standard table sugar. Let's have a look what happens here. Pour a bit of sugar onto the watch glass. Electrodes touching, always just checking our circuit's still good. Yep, the circuit is still good. But when we touch the electrodes to the sugar, of course, as we've seen before, nothing happens. The lamp isn't glowing. Well, that's okay. We know what to do, don't we? We can pour our sugar into some water. Give it a bit of a stir around. Now, like the salt, not all of the sugar has dissolved. We know sugar does dissolve in water quite readily, but that's okay. We just need a little bit dissolved for now. And place your bets. What do you think will happen? Well, testing our circuit, touching the electrodes. Yep, we're good to go. Let's put the electrodes in the solution. We'll dip one in, and then I'll touch the other in, and watch what happens to the lamp. Hold up, nothing happens. Touch the electrodes, complete the circuit. Now, we said before that when we dissolve ionic compounds by putting them into water, we have ions that are free to move through the solution, and therefore that's a flow of charges, which is electrical current. And yet we don't have electrical current flowing now. Well, the thing is, sugar actually isn't an ionic compound. A lot of people think it is because it does dissolve quite readily. It does, but that's for a different reason. That's because it's essentially surrounded around the compound with lots of hydroxyl groups, lots of OHs. So that's why sugar will dissolve in water, but it's not an ionic compound, which means it can't dissociate into cations and anions. It can't dissociate into constituent ions because it's literally not made from ions. So there we go. Sugar doesn't conduct because it's not ionic, but the two ionic compounds we looked at, hydrated copper 2 sulfate and sodium chloride, when we have ions in solution, they are free to move, they will conduct current. Well, that's the video done. If you liked it, brilliant. Hit the like button and leave me a comment too. Now you know what to do. Go hit that subscribe button. We'll see you next time.